Welcome to a course on linear algebra. We are going to work out few more problems on checking linear independence of vectors in this lecture. Let us get into the lecture. In this lecture, the metric space that we have considered is the space of 2 cross 2 matrices with real entries. Okay, and we are asked to consider the following subsets of this M2RR, and we have to check which among this is a linearly independent one, right? And here you may notice something. Okay, first let us come to the third problem. Here what they have done, they have taken the entire vector space as a subset, and we are asking to check for the independence. Will it be linearly independent? No, because if you take any matrix, okay, for example I am taking this matrix. If this is a member of M2R and we know that this is also a member of M2 of R, when you check these two things, you have what? These two are linearly dependent. When you put these two alone in a single matrix, this set is a linearly dependent set. Any superset of a linearly dependent set is linearly dependent, therefore it is not linearly independent, right? Okay, now we'll move to the first and second options, right? Here, okay, first of all let us start with a simple idea. In order to write a 2 cross 2 matrix, how many entries do you need? A, B, C, D. Okay, these 4 entries has to be real numbers. That is the element of these sort of elements are present in M2 of R, right? So in order to write a matrix completely, we need 4 entries, which means this may be simply written as A000 plus 0B00 00C0 plus 000D. This is the least possibility, right? You may have some entry so that the adjustment can take place. It is fine, that is well and good. Okay, to the maximum you will have 4 matrices. When you add these 4 things, you are going to get this one, which means an element in M2 of R can be written if we know 4 values. So if you have a set consisting of more than 4 matrices, that is of course linearly dependent. That cannot be linearly independent. Using that idea, can we eliminate any one of this option? Yes, we can eliminate the first option, right? Since it contains how many vectors? It contains 5 entries of this set, hence it cannot be linearly independent. Okay, suppose if this question is asked in MCQ, then we will take that we have eliminated these 2 options and finally we will come to a conclusion that this is linearly independent. Here let us check that too. Okay, in order to check the linearly independence, what do? We make a linear combination, right, plus some gamma times of 1 1 1 4, which is to be equated to 0 0 0 0, and when you perform the operations, you are going to have what? Alpha plus beta plus gamma, alpha plus beta plus gamma, alpha plus beta plus gamma, alpha plus 2 beta plus 4 gamma, and this is to be equated with 0 0 0 0. Okay, and when you write these things out, the distinct, if it is going to give you a unique solution, that is a trivial solution, you can conclude what? These are linearly independent. Do we have any other options? That we have to check, right? So hope you remember some methods from your schooling. Let me write alpha to be 1 1 2 4 and beta to be 1 1 1 4 and minus beta, right? Minus gamma has 1 1 1 2 and this is going to give you alpha upon 2 minus beta upon 3, which is equated to gamma upon 1, right? So you have several possibilities are there for it, which means what? Which means this set is also not linearly independent, right? This is why I said that let us check these things and come to a conclusion, right? Now we are considering P3 of R. What sort of elements this P3 of R has? This is a polynomial of utmost degree 3, right? This A, B, C, D are entries taken from the set of real numbers, and it is considered to be the vector space over R. Now we are considering some subsets of this one, and we are going to check whether these are linearly independent or not. Now you may see, in order to write x cube coefficient, x cube, we need something. Similarly here, to the maximum, if we have 4 things, we can write the elements in P3 of R. And this is the idea that tells you if you have a set more than 4 elements, that cannot be linearly independent. Now check, do you have any elements which do you have any sets which has more than 4 elements? This set has. So this cannot be linearly independent, right? And now let's do one by one. First thing, let me take alpha times of that thing, beta times of this, and gamma times of this, and delta times of this is equated to 0. 0 means you will have to equate to the 0 element in this set. So the 0 element in this set is 0 plus 0x plus 0x square plus 0x cube. Just do the just equate the like terms. So what will you get? You will get alpha to be equal to 0, beta to be equal to 0, gamma to be equal to 0, and delta to be equal to 0. Therefore it is linearly independent. Now let us come to the second one. That is alpha times of 1 plus x, beta times of 5 plus x squared, plus gamma times of 7 plus 3x cube, and is to be equated to 0 plus 0x plus 0x squared plus 0x cube, which is the 0 element in this set P3 of R. Now if you do the calculations, what will you get? You will get alpha plus 5 beta plus 7 gamma. I am just segregating the constant terms out, and then the x terms, that is alpha x plus beta x square plus 3 gamma x cube, which is equated to these things. And when you equate the like terms, what will you get? You will get alpha plus 5 beta plus 7 gamma is 0, and alpha is 0, beta is 0, 3 gamma is 0. So this gives you gamma is 0. So you have directly got alpha, beta and gamma are 0. This equation is also satisfied, and hence it is also linearly independent. Using the same idea, we will have to check for the linear independence of the third one. Okay, let us do that. Alpha times of 1 minus x plus x squared plus beta times of 5 plus x plus 7x squared, which is to be equated to 0 plus 0x plus 0x squared plus 0x cube. This is what? Alpha plus 5 beta. When I take the constant terms out, then minus alpha plus beta times of x plus alpha plus 7 beta times of x squared, which is to be equated to these things. Okay, when you equate the like terms, you have what? Alpha plus 5 beta is 0, minus alpha plus beta is 0, alpha plus 7 beta is 0, and when you try to put it in a matrix form, okay, you have this is to be alpha beta, and you have 0 0 0 here, right? What is, if you consider this matrix to be A, what is the rank of this matrix? This is 2. This is same as that of the number of unknowns. So what you have this leads to a unique solution. Since this is the homogeneous system, this leads to what? A trivial solution. That means alpha and beta are 0, and hence this is a linearly independent set. Right? In the upcoming lecture, we will see some properties of this linearly independent vectors, and we'll define something called basis of a vector space. Thank you.